Hi, welcome back to Physics 150. This is tutorial number 8. Okay, tutorial 8 is AC circuit or LC circuit, yeah. Okay, tutorial 7. Sorry, tutorial 8. AC circuit. Okay, AC circuit number 1. A series circuit consisting of 12 ohm resistor, 110 microfarad capacitor, and a 50 millihenry inductor are connected across a 24 volt 50 hertz power source. Okay, even though it don't say 24 volt is what, yeah, it should be a AC power supply. Okay, this AC power supply is 24 volt, should be root mean square. Okay, and then with a frequency of 50 hertz. Okay, that's how we understood it. Now we have 3 components connect to it. First component is a resistor, followed by a capacitor, okay, and then followed by an inductor. Okay, so this one is resistor 12 ohms. This is a capacitor of 110 microfarad, inductor of 50 millihenry. Okay, 50 millihenry. Okay, compute the capacitance and inductance reactant. Okay, reactant is their dynamic resistance value. Yeah. So capacitance we already, resistor we already have. Now capacitance is called the chi c. Is given by 1 over 2 pi fc. Okay, 2 pi fc value. So we put in the value and calculate what's the value given. 2 pi. 50 hertz capacitance is 110 microfarad. Okay, 2 pi times 50 hertz times 110 micro. Okay, and then we have 28.94. Okay, 28.9 ohms. Okay, 28.9 ohms. And then chi L is the reactant for inductor. So our formula is 2 pi FL, and the inductance is 50 millihenry. Okay, so we have 2 pi times 50 times 50 millihenry. So we have 15.7 ohms. Okay, 15.7 ohms. The unit for reactant are the same. Yeah? Next one is the impedance. Okay, the impedance is a total okay, the total resistance and reactance in an AC circuit. So the impedance Z is given by this formula, is R squared plus chi L minus chi C squared. Okay, so you have 12 here square plus chi L is 15.7 minus this 28.9, but it doesn't matter because you got square, so don't worry about the negative value in the square root. Alright, we have 15.7 minus 28.9, and then we square it, and then plus 12 square, and we cube root everything, 17.8. Okay, 17.8 ohms. That is the impedance. Okay, impedance is symbol Z. Yeah? Next one, the current in the circuit, C. So we use Ohm's law. We use that the current Ohm's law is V equal to IR. But since the total circuit here have a reactant and also resistance of impedance Z. Okay, so our voltage is given 24, so current, and then this one is 17.8. So we get a current of 24 divided by 17.8, so we get 1.34. Okay, 1.35 volt. Okay, 1.35 volt. Next one, voltage across. What is the meaning? Voltage across. Okay, the voltage across our capacitor and inductor. So voltage across capacitor is the I you calculate and the chi C. So 1.35 times chi C is this one, 28.9. So 1.35 times 28.9, 39 volt. Next one is a VL, which is I chi L. 1.35, and it is 15.7. We have 1.35 times 15.7, so I got 21.2. Okay, 21.2 volt. Right, 21.2 volt. So that is a true value. Question number 1. Okay, next question number 2. Question number 2 is a LRC. Okay, LRC is something like this. An LRC series is the simplest LRC circuit, AC circuit, consisting of inductor, L32 resistor, and capacitor connected across a 10 kHz 725 source. Determine reactant. Okay, same story here. Okay, same story here. So we just draw that circuit. We use that one to help us, to guide us to solve the problem. Okay, because diagram can easily, very helpful actually. So first is this one, and then capacitor, and then inductor. The arrangement is not important. Yeah? Resistor is 8.7 kilo ohm, capacitor is 6250 picofarad, inductor is 32 millihenry, and the voltage here, root mean square, is 725 volts at a frequency of 10 kilohertz. Okay, next, calculate reactant. It seems that the RLC circuit are actually doing the same thing all over and over again. Chi L 2 pi FC, and this one will be 2 pi, frequency is 10 kilo, and FL, the L is 32 milli. Okay, so we have 2 pi times 10 power 3 times 32 power negative 3, so we have 2011. Okay, 2011 ohms. Okay, that's our first one. All right, next is the chi C is equal to 1 over 2 pi FC. So now we have 2 pi 10 power 3, and then we have that LRC value is 6250 pico is minus 12. Okay, 1. Okay, let's check. 2 pi times 10 power 3 times 6250 power negative 12. Right, so we have 2546 ohms. Okay, 2546 ohms. Yeah. Next one, the impedance Z. Well, impedance is a total, right? So same formula, R square plus chi L minus chi C square. Square root everything. So resistor 8.7, 8700 square plus chi L is this one, 2546 minus 2011, and square, then square root everything. Okay, so at 2546. Okay, 2546 minus 2011, we squared, and then plus 8700 squared, and then we square root everything. Okay, so we have 8716 ohm. That is a total. Okay, total resistance and reactant in a AC circuit. C, the phase angle. Okay, what is phase angle? Phase angle is related to the power factor. Okay, I'll do power factor first. Okay, I'll do power factor first. Okay, related, yeah. So power factor PF is actually equal to cosine phi, and this value is R over Z. Okay, it is R over Z. Okay, R over Z. So you have this power factor formula of your R is 8700 divided by 8716. So we have 0 point something here. 8700 divided 8716. So it is 0.998. Now that power factor 0.998, that means that that AC circuit efficiency is 99.8% if you multiply this one by 100%. Yeah. Now this one is a phase angle. Okay, this one is a phase angle. So we have phase angle is equal to 0.998. So we calculate this value. How many angle? cosine. Very small angle, right? Okay, very small angle. 3.5. Let me check. Oh, is it correct or not? Okay. 0. We use up cosine 0.99 at, see what do we have here? 3.6. Okay, 3.62. Okay, 3.62 degree, which is this one is different. I wonder why. Okay, so 3.62. Yeah. So angle 3.62. Then if it is 8.1, how do you get 0.9? Let's check. Maybe they use a value that is already. Oh, no wonder. It's because of the 8 here. So if you use a more accurate value, normally I follow 3 significant figures, so I get a more accurate value here. Okay, so that is your C. Now D also power factor. Now E. E is I root mean square. So we use V root mean square is equal to I root mean square multiplied by Z. So this one is already given 725. Okay, so I root mean square you have to divide by 8716 to get your I root mean square current. So 725 divide by 8716. Okay, current is 0.0832. 0.0832 ampere. This is root mean square. Okay, done for question 2. It repeats over and over again the same type of thing they ask you, right? Okay, next one, question 3. Okay, question 3 is the following table give the reactant and the root mean square voltage across the element of a series RLC. Resistor, this one, the voltage 86. Okay, capacitor, this one. Okay, so what is the root mean square voltage of the circuit? The root mean square voltage. Okay, we actually simply just sum them up. Okay, if you look at the circuit, is given also, so we can use that same circuit. Okay, so we have resistor, we have capacitor, and then we have a inductor here. Okay, we have an inductor. So this is, I call this is R, this is C, this is L. So this is our V root mean square, frequency F unknown. Okay, now what is the root mean square voltage? Number A. Because you're already given the value here, VR, this one is VC, and this one is VL. Okay, VL. So our V root mean square in this case is the sum of all their voltage at that particular instant. Yeah. Okay, so we have 86 plus 285 plus 162. Okay, let's check. 86 plus 285 plus 162. So I have 533. Okay, 533 volt root mean square. Okay, root mean square. Alright, next B. What is the impedance of the circuit Z? Okay, how to get the Z value? You already have this, right? This value is given, so you have to calculate the the reactant is already given, so you straight away use that formula. R square plus chi L minus chi C square. Alright, so the value is, this one is 200 ohm square plus this one is 663. Okay, no, later balik. This one is 377. Okay, 377 minus 663 square, and then everything square root. Okay, check. 377 minus 663 squared, and then we plus 200 square and square root everything. So I got 349 ohms. That is our impedance Z. Okay, impedance Z. C. What is the root mean square current? Okay, our V root mean square is equal to I root mean square Z. So this one is already calculated in number A. So your I root mean square you need to divide by 349. Okay, so the I root mean square is equal to 533 divided by 349. So you got 1.53 ampere root mean square again. Okay, D. Determine the peak voltage of the AC supply. Now, the V root mean square is equal to the peak voltage divided by square root 2. So the peak voltage, which is normally we use VP, is equal to V root mean square multiplied by square root 2. That is 533 square root 2. Okay, so what's the value? 533 times square root 2. Yeah. Okay, we got 754. Okay, 754 volt. Next one, E. What is the phase angle blah 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 between the current and the supply voltage? The phase angle, well, we use this one. Remember, this one is R over Z. So we calculate this one is equal to arc cosine R over Z, or this one, R is 200 and your Z here is 349. Okay, 349. So arc cosine, we have 200 divided by 349. We get 55 degree. Okay, 55 degree. Again, something is wrong here. Okay, 55 degree. And last one, F. Okay, F. What is the power factor? Power factor is cosine phi. Okay, so cosine phi here is cosine 55. Okay, cosine 55. So I got 0.57. Okay, cosine 55. So I got 0.57. Okay, 0.57. Yeah. Okay, done for question number 3. This is page 1. Okay. Okay, next question. Question number 4. Oh, last question actually. Okay, last question number 4. Okay, question 4. A coil has an inductance of 0.1, okay, and resistance of 10 is connected in series, okay, with 10 microfarad is connected to a line. Line means a lifeline, okay, AC power supply. So this line is 110 root mean square, 110 volts, frequency of 60 hertz. Some country have this, but not our country. Okay, it has inductor, and then the inductor, the wire has a resistance, okay, and then it's connected in series to a capacitor. All right, so the L is 0.1 Henry, and then the resistor in the wire is 10 ohms, and the capacitor connector is 10 microfarad. Okay, so determine impedance. Well, impedance here, this one have a little bit more to calculate, because you have to calculate chi L first. 2 pi FL. Okay, so 2 pi frequency 60, your L is 0.1. Okay, so we have 2 pi times 60 times 0.1, so 37.7 ohms. Number 1, chi C, 1 over 2 pi FC, so 2 pi 60, and the C is 10 microfarad. Okay, we have 2 pi times 60 times 10 micro. Okay, so 265 ohms. Okay, 265 ohms. So the impedance is this one, R square chi L minus chi C square, square root everything. Okay, so we have resistor 10 square. Chi L is 37.7 minus 265 square, square root. Okay, 37.7 minus 265, squared plus 10 squared and square root everything. We got 227.5. Okay, 227.5 ohms. Next one, okay, B. Okay, the B, they want a current through the circuit, so V root mean square is equal to I root mean square times Z. This one is 110. Your I root mean square, this is 227.5. So your root mean square current is 110 divided by 227.5, 0.484. 0.484 ampere. Okay. This one is wrong already. Okay, is it correct? See, 110 divided by 227.5. There's a 1, 0.48. So this one is wrong. Next. Okay, our next one is number C. Phase angle between. So we have to calculate power factor first. Okay, we do power factor first. Yeah. Power factor is equal to cosine phi, and which is equal to R over Z. So in this case, it is 10 over 227.5. Our case, 10 divided by 227.5. Now it is 0.044. Okay, 0.44. So it's only 4.4%. It's a lousy system. Okay, 4.4% efficient. Okay, now go back to this one. Cosine phi is equal to 0.044. So our phi is up cosine 0.044. Okay, so now we're going to have this value up cosine. So 87.48. 87.48 degree. 87.5 degree. Okay, 87.5 degree. So power factor 0.044. This one correct? Correct. No, something wrong here. Last one, E. E is the voltage reading across inductor. So the voltage across reading inductor is a I root mean square multiplied by chi L. Okay, chi L. So current just now 0.484 times chi L. What is our chi L now? Chi L is 37.7. So we have 0.484 times 37.7. So we have 18.2 volt. Okay, and next one is the VC, which is I root mean square, and then this one is chi C. Okay, 0.484 multiplied by C is 265. So 0.484 times 265. So we have 128.3 volts. Okay, 128.3 volts. All right. Okay, here. Okay, done. This is page 2. So for this question, it's because this one wrong. So this one is wrong. This one is wrong. This one 227.8 is correct. So I assume their chi L and chi C is correct. Okay. So because current is wrong, so you get the wrong answer compared to mine. All right. So that's it.